Welcome, everyone. We'll explore the fascinating world of artificial intelligence, delving into its various branches and applications. Our focus will be on understanding the core components and the transformative impact of AI technologies in our daily lives and across different industries. By the end of this session, you will have developed a foundational understanding of key AI concepts and technologies. You will explore the practical applications of machine learning, deep learning, NLP, and generative AI. The session will also help you gain insights into how these technologies are transforming industries such as finance, healthcare, and customer service. Furthermore, you'll be able to identify potential use cases for AI within your own organization. Before we jump into the session topics, let's have a quick recall of what AI is. At its core, AI is about creating machines that can mimic human intelligence. Imagine having a computer that can think, reason, and make decisions just like a person. This isn't about robots taking over the world, but rather machines helping us solve complex problems more efficiently. For example, AI can help doctors diagnose diseases more accurately or enable cars to drive themselves safely. Next, we'll explore the key areas of AI, starting with machine learning. So, what is machine learning? You probably use machine learning many times a day without even realizing it. Anytime you want to find out something like, how do I make a gluten-free cake? You can do a web search on Google. The search works so well because Google's machine learning software has figured out how to rank web pages and give you the most relevant ones. Every time you use voice to text on your phone to write a message like, hey, how's it going? Or tell your phone, hey Siri, play a song by Taylor Swift. Or ask, okay Google, show me Indian restaurants near me. That's also machine learning in action. Machine learning is increasingly being used across industries. In healthcare, machine learning helps doctors diagnose diseases more accurately by analyzing medical images like X-rays or MRIs. In finance, machine learning can detect fraudulent transactions faster than a human can. For example, if your credit card is used in a different country, the system might flag it as suspicious. Farmers use machine learning to predict how much crop they will harvest, helping them make better decisions about planting and harvesting. Manufacturing factories are using computer vision powered by machine learning to inspect items coming off the assembly line for defects. Now that we've seen several personal and industry use cases of machine learning, let's try to understand what machine learning is. Arthur Lee Samuel, an American pioneer in the field of computer gaming and artificial intelligence, popularized the term machine learning in 1959. He defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Arthur Samuel's groundbreaking work in the 1950s involved creating a checkers playing program. Despite not being a skilled checkers player himself, Samuel programmed the computer to play thousands of games against itself. By analyzing which board positions led to wins or losses, the program learned to identify good and bad positions. Over time, it improved its strategy, eventually becoming a better checkers player than Samuel. This early milestone in machine learning showcased how computers can learn and improve from experience without explicit programming for every scenario. So, how does machine learning work with such high intelligence? Think of machine learning like teaching a child. Just as children learn from their experiences, machines can learn from data. In machine learning, we feed computers large amounts of data, and they use this information to make decisions or predictions. Next, we're going to discuss how machine learning is helping in daily life. A simple example is how your email service uses machine learning to filter out spam emails. It learns from millions of emails to understand which ones are spam and which are not. Over time, it gets better at filtering, just like how practice makes a child better at riding a bike. Another example can be detecting fraud in banking transactions. Banks need to find and stop fake transactions, fraud, before they cause problems. Imagine if someone stole your bank card and started misusing it. The bank needs a way to catch these fake transactions quickly. The bank gathers lots of information about each transaction. This includes details like the amount of money spent, the time, the location, and where you usually shop. The bank uses past data where they know which transactions were real and which were fake. They teach the machine learning model by showing it examples of both real and fake transactions. The machine learning model looks for patterns. For example, it might learn that someone usually shops in their home city, and if a transaction happens in another country, it could be suspicious. Once the machine learning model is trained, it can start looking at new transactions in real time. It uses what it learned to decide if a new transaction looks real or fake. If the machine learning model thinks a transaction is fake, it can alert the bank or even stop the transaction right away. This helps protect people's money and stops fraudsters from stealing. To understand how machine learning works, think about teaching someone a new skill. First, we collect data. For example, if we want a computer to recognize cats, we collect many pictures of cats. Next, we prepare this data by cleaning it up, such as removing blurry images or irrelevant pictures. Then we train the model by showing it all these pictures. The model starts to learn what features make up a cat. Training is followed by testing. We test the model to see how well it learned. We might show it new pictures of cats and see if it can recognize them. Finally, we deploy the model so it can start making decisions on new data it has never seen before. Next, let's discuss what are the different types of machine learning. There are different types of machine learning, each with its own approach. They are supervised, unsupervised, and reinforcement. Let's cover supervised learning first. Supervised learning is like a teacher showing a student flashcards with the answers on the back. In this method, the machine learning model learns from examples that are already labeled. For instance, imagine showing a machine learning model a series of pictures with labels such as cat, dog, or horse. Each image is paired with its correct label, allowing the model to learn the distinguishing features of each category. Over time, the model becomes proficient at recognizing and classifying new unseen images based on the patterns it learned from the labeled examples. This process helps the model make accurate predictions and decisions when it encounters new data. In manufacturing, predictive maintenance is crucial to minimize downtime and maximize efficiency. Imagine a factory floor with hundreds of machines operating continuously. Each machine is equipped with sensors that collect data on various parameters like temperature, vibration, and performance metrics. Using historical data labeled with past failures and normal operations, supervised learning models, such as regression, are employed. These models analyze the sensor data to predict when a machine is likely to malfunction or require maintenance. By predicting potential failures in advance, manufacturers can schedule maintenance during planned downtime, preventing costly breakdowns that could halt production unexpectedly. This application of supervised learning not only saves money, but also improves operational reliability by ensuring machines are serviced before they fail. We will next cover unsupervised learning. Unsupervised learning is like giving a student a stack of flashcards without any answers and asking them to group similar cards together. In this approach, the computer is given data without explicit labels. Instead of being told what to look for, the machine learning model analyzes the data to find hidden patterns and relationships. For instance, imagine feeding a machine learning model a collection of images without any labels. The model will examine the images and try to cluster them into groups based on their similarities. It might group all the images of cats together, separate from the images of dogs and horses, based purely on the visual features it detects. Unsupervised learning is powerful for tasks like clustering, where the goal is to discover natural groupings in data. It's also useful for simplifying complex data while keeping the important details intact. This type of learning helps in scenarios where labeled data is scarce or when exploring the underlying structure of complex datasets. Retailers use unsupervised learning to gain insights into customer behavior without needing predefined categories. Consider a large retail chain with millions of transactions occurring daily across various stores and online platforms. Unsupervised learning uses clustering algorithms to analyze transaction data and group customers based on similarities in their purchasing habits. These algorithms identify segments such as frequent buyers, seasonal shoppers, or budget-conscious consumers. By understanding customer segments, retailers can tailor marketing strategies and promotions to specific groups, improving customer engagement and increasing sales. This use of unsupervised learning can also help retailers optimize inventory management, personalize customer experiences, and ultimately drive profitability through targeted marketing campaigns. Another type of machine learning approach is reinforcement learning. Reinforcement learning is similar to how we learn from our mistakes, like learning to ride a bike by falling and trying again. The computer learns by receiving rewards or penalties based on its actions, kind of like a game. Imagine a scenario where you are training a dog. When the dog fetches the ball, it gets a reward. If the dog goes in the wrong direction, it doesn't get a reward and might receive a gentle correction. The dog starts at a certain point and tries different actions to reach the ball. Positive feedback in the form of rewards encourages the dog to repeat successful actions. Negative feedback in the form of penalties discourages incorrect actions. Over time, the dog learns the best way to fetch the ball by understanding which actions lead to rewards. Similarly, in reinforcement learning, the system starts with little knowledge and tries various actions. It receives rewards for actions that bring it closer to its goal. Over time, it learns the most effective strategies to achieve its objectives by maximizing rewards and minimizing penalties. In reinforcement learning, we have an agent, which is the learner or decision maker. In our earlier example, the dog is the agent trying to learn the best way to fetch the ball. The environment is everything the agent interacts with. For the dog, the environment includes the yard, the ball, and any obstacles. The state represents the current situation of the agent within the environment at a specific time. For the dog, the state could be its position relative to the ball. The action is what the agent decides to do based on the current state. For the dog, actions could include running, stopping, or changing direction. The reward is feedback from the environment based on the agent's action. It can be positive or negative. For the dog, fetching the ball successfully results in a reward by the owner with a treat, while going in the wrong direction might result in no reward or a gentle correction. Autonomous driving represents a pinnacle of reinforcement learning, where vehicles learn to make decisions by interacting with their environment and receiving feedback in the form of rewards and penalties. Imagine a self-driving car navigating through city streets. It encounters various scenarios, such as traffic lights, pedestrians crossing, and other vehicles merging. Through simulations and real-world testing, these cars learn to navigate safely and efficiently. Reinforcement learning algorithms allow the car to adjust its driving behavior based on rewards for safe actions, such as stopping at red lights, and penalties for risky behaviors, such as near-miss incidents. This technology aims to revolutionize transportation by reducing accidents, improving traffic flow, and providing mobility solutions for elderly or disabled individuals. Let's have a just-a-minute session. You can pause the video and try answering the question. The correct answer is option C. The primary goal of reinforcement learning is to learn by interacting with an environment and receiving rewards or penalties. Let's have another just-a-minute session. You can pause the video and try answering the question. The correct answer is option B. In the context of reinforcement learning, an agent is the learner or decision maker. Let's have one more just-a-minute session. You can pause the video and try answering the question. The correct answer is option A. A teacher showing a student flashcards with the answers on the back is the best fit for supervised learning. Deep learning is a more advanced type of machine learning. It's like taking machine learning to the next level. Deep learning focuses on enabling machines to automatically learn complex patterns from large amounts of data. This data can be images, text, audio, or any other format that can be represented mathematically. Unlike traditional machine learning algorithms that rely on handcrafted features, deep learning models can discover these features themselves. Deep learning is integrated into numerous aspects of our daily lives, often in ways we might not even realize. When you upload pictures to Instagram or Snapchat and think to yourself, I want to tag my friends so they can see their pictures, these apps can recognize your friends in your pictures and label them. That's deep learning using image recognition technology. Deep learning is also the technology behind your phone's facial recognition system, enabling it to unlock securely by recognizing your unique features. In self-driving cars, deep learning algorithms process vast amounts of sensor data to understand the road, recognize obstacles, and navigate safely, ensuring a smooth and secure journey. Let's now try to understand how things happen in deep learning. Let's start with the human brain, which is a complex network of neurons that work together to learn and understand the world around us. Deep learning takes inspiration from this natural phenomenon. It uses artificial neural networks, which are like simplified versions of the brain's neural pathways. These networks have multiple layers, and each layer processes information from the previous one, gradually extracting more complex features from data. Deep learning starts with input data, which can be anything from images and text to audio and video. Think of it like giving the model raw materials to work with. This data forms the foundation on which the model builds its understanding. Before the data is fed into the neural network, it often undergoes pre-processing steps to ensure it's in the best possible format for learning. Next, we have the layers of artificial neurons, which make up the neural networks. These layers function like a series of sieves, extracting increasingly complex features from the input data at each stage. Imagine peeling back layers of an onion, where each layer reveals more details and patterns. This hierarchical structure allows the model to learn intricate representations of the data, which is crucial for tasks like image recognition and natural language processing. The real magic happens during the training phase. Here, the model learns from labeled examples, adjusting its internal parameters to minimize errors in its predictions. It's similar to how students learn from examples in a classroom setting. The model goes through numerous iterations, constantly refining its understanding to improve accuracy. Hyperparameter tuning, such as adjusting the learning rate and batch size, helps optimize this learning process. Finally, once the model is trained, it enters the inference phase, where it makes predictions or decisions on new, unseen data. This is where the model applies what it has learned to real-world scenarios, much like a graduate applying their knowledge in their job. The model's performance is often evaluated using metrics like accuracy and precision to ensure it meets the desired standards. And in some cases, the model continues to learn from new data, further enhancing its capabilities over time. There are three types of deep learning models: artificial neural networks, convolutional neural networks, and recurrent neural networks. Imagine you're showing vacation photos to your friend. You can easily tell which pictures are on the beach because of the sand, palm trees, and maybe even an ice cream cone in your hand. Your brain makes connections between these details to identify the scene. Artificial neural networks, ANNs, are computational models inspired by the human brain. They consist of layers of interconnected nodes, neurons, that work together to process information and make decisions. To understand how an artificial neural network, ANN, works, let's consider a simple example of predicting house prices based on the size of the house. First, we input the size of the house, say 1,500 square feet, into the input layer. This data is then passed to the hidden layer, where neurons process it by applying weights, biases, and an activation function. For simplicity, let's assume there are 3 neurons in this layer. One focuses on smaller houses, another on medium-sized houses, and the third on larger houses. Each neuron processes the input size differently based on its focus. The processed information is then passed to the output layer, which combines the results from the hidden layer neurons to produce the predicted price of the house. Convolutional neural networks, CNNs, are a type of artificial neural network designed to process and analyze visual data like images and videos. They are particularly good at identifying patterns, shapes, and objects within images, making them powerful tools for tasks such as image recognition and classification. Imagine you have a smartphone with a photo gallery app that can automatically sort your photos into different albums, like family, friends, nature, and food. Here's how a CNN helps with this task. You take a photo of a beach sunset with your phone. The CNN's first layers scan the photo using small grids. These grids detect basic features like edges, colors, and textures. For example, one filter might detect the edges of the sun, another might identify the color gradients of the sky, and another might notice the texture of the water. The CNN reduces the size of the data by summarizing the important features. This makes the processing faster and helps the network focus on the most significant parts of the image, like the sun, sky, and water. The CNN takes these summarized features and analyzes them to determine what the photo is. It combines the information about the edges, colors, and textures to conclude that the photo is of a beach sunset. The CNN classifies the photo into the nature album. Recurrent neural networks, RNNs, are a type of artificial neural network designed to process sequential data, meaning data where the order of elements matters. They are particularly useful for tasks involving time series, text, speech, and other sequences. Imagine you're using a smartphone that suggests the next word as you type a message. Here's how an RNN helps with this task. You start typing a message, "I love to eat ice." The RNN processes each word in the sequence, one by one. As it reads, "I love to eat," it remembers these words and updates its hidden state accordingly. The RNN uses its hidden state to understand the context of the message. By the time it reaches ice, it has a good understanding of what you're talking about. Based on the context and the words processed so far, the RNN predicts the next word. It might suggest cream as the next word because it has learned from patterns in similar sentences that ice cream is a common phrase. Now that we have learned about deep learning, let's look into another critical subset of AI, which is natural language processing, or NLP in short. Let's have a just a minute session. You can pause the video and try answering the question. The correct answer is option B. Deep learning models process information using artificial neural networks with multiple layers. Think about the way humans understand language. From a young age, we effortlessly learn to understand and generate language. For example, when your friend tells you, "I need to pay my internet bill, but my salary hasn't arrived. Can you help?" We instantly understand the meaning and the context. We know your friend is asking for money and probably soon. This understanding comes naturally to us, but for machines, it's a significant challenge. Computers are good at following instructions by interpreting data as ones and zeros, but they don't naturally understand the way we speak. Understanding the nuances, context, and emotions in human language is incredibly complex. This is where natural language processing, or NLP, comes in. Christopher D. Manning, a computer scientist and applied linguist at Stanford University, defines NLP as a set of methods and algorithms for processing natural language data, which includes text and speech, to allow computers to derive meaning from it. In non-technical terms, NLP is a branch of artificial intelligence, AI, that focuses on enabling computers to understand, interpret, and respond to human language in a valuable way. It bridges the gap between human communication and computer understanding. NLP is important because it helps computers understand us better. This improves how we interact with technology. Imagine trying to use your phone or computer without being able to talk to it or type in your language. It would be much harder. In many things we interact with every day, NLP keeps working under the hood. When we use Google Translate to translate languages instantly, that's also NLP at work. For instance, if you type a sentence in English and need it translated to French or Spanish, Google Translate uses advanced NLP techniques to understand the structure and meaning of the sentence in English and then generate an accurate translation in French or Spanish. Not only sentences, AI solutions like Google Translate can perform the translation of images, documents, and even an entire website. Some solutions can perform advanced speech and video translations. And in all these, NLP plays a major role. For example, if you ask a chatbot, "How do I reset my password?" the chatbot identifies the key elements of your question, the action reset and the object password. It then retrieves the appropriate information from its knowledge base to provide you with a step-by-step guide on resetting your password. Sentiment analysis is another fascinating application of NLP. It enables companies to gauge public opinion and understand how people feel about their products by analyzing comments on social media, customer reviews, and other forms of online feedback. For instance, when people post reviews about a new smartphone on social media platforms, sentiment analysis algorithms can sift through these posts to determine whether the feedback is positive, negative, or neutral. Let's have a just a minute session. You can pause the video and try answering the question. The correct answer is option B. Google Translate uses NLP by understanding and translating the structure and meaning of sentences. Let's have a just a minute session. You can pause the video and try answering the question. The correct answer is option B. Chatbots use natural language processing to understand and respond to human queries. Let's have a just a minute session. You can pause the video and try answering the question. The correct answer is option B. The primary goal of sentiment analysis is to understand how people feel about a product or service. Now, to have a better understanding of GenAI, let's imagine a painter who studies the works of great masters like Van Gogh, Picasso, and Monet. By learning from their techniques, colors, and styles, the painter develops her own unique painting. GenAI, which is a subset of AI, works in a similar way. It is trained on vast amounts of data, such as paintings, poems, or music. By analyzing these examples, GenAI learns the underlying structures and patterns that define different creative styles. The more data GenAI processes, the better it becomes at generating unique and original content. With this knowledge, GenAI can then produce new content that is inspired by the data, but remains original and unique. For instance, it can create a new painting that blends elements of various art styles, compose a song that resonates with familiar musical patterns, or write a story with a compelling narrative structure. So in short, GenAI is a subset of artificial intelligence that creates new content by learning from existing data. It can generate text, images, music, videos, and more, mimicking the patterns and structures of the data it was trained on. And how exactly does GenAI do this? It is through generative models. There are different types of GenAI models, and let's first take up GAN, a shorter form of generative adversarial networks. GAN was introduced by Ian Goodfellow, an American computer scientist most noted for his work on artificial neural networks and deep learning. GANs consist of two neural networks, a generator and a discriminator, that compete against each other. The generator creates data, like images, while the discriminator evaluates them. This back-and-forth competition results in incredibly realistic outputs. Next, let's look at some use cases of GAN. First up is image generation. GANs can generate high-resolution images. Need a realistic portrait but don't want to use a real person's photo? GANs can create lifelike faces of people who don't exist, and it's incredible how realistic they look. In fashion, GANs can design new clothing. Designers can input existing trends, and GANs will generate innovative, trendy clothing designs. GANs can also generate realistic interior design layouts and furniture arrangements. For product prototypes, GANs can design realistic new products, from electronics to household items. This helps companies visualize and refine products before production. In medical imaging, GANs create synthetic MRI and CT scans. These are invaluable for training medical professionals and improving diagnostic tools without using real patient data. Lastly, GANs can generate sound and music. They can create realistic audio clips, synthesize human speech, and even compose original music, enhancing everything from virtual assistants to entertainment. So, from high-resolution images and trendy fashion designs to stunning product prototypes, medical imaging, and music, GANs are revolutionizing both the creative and technical worlds. The next generative model is GPT, or Generative Pre-trained Transformer, developed by OpenAI. So what makes GPT so special? GPT is a powerhouse in text generation. It excels at creating human-like text, summarizing content, translating languages, and even engaging in meaningful conversations. We all know ChatGPT. It can hold a natural conversation, help you draft a blog post, summarize lengthy articles, and translate content across different languages. That's GPT in action, transforming the way we generate content. Some other generative models worth mentioning are DALL.E, which combines language understanding with image generation. You can give it a textual description, like a cat in a spacesuit, and it will generate an image that matches that description. Then we have WaveNet, which is all about audio. It generates human-like speech and other audio signals, making it a game changer for text-to-speech systems. The quality of the speech it produces is so natural that it's used in virtual assistants, improving accessibility tools, and even in dubbing for films and TV shows. And also, OpenAI Sora in the realm of text-to-video. Imagine typing a script and having an AI generate a complete video based on that text. Sora analyzes the script, understands the context, and produces a video with appropriate visuals, transitions, and effects. Let's have a just-a-minute session. You can pause the video and try answering the question. The correct answer is option D. Deep learning is used behind facial recognition systems in smartphones. Let's have a just-a-minute session. You can pause the video and try answering the question. The correct answer is option B. Unsupervised learning involves grouping similar data without labels. Let's have a just-a-minute session. You can pause the video and try answering the question. The correct answer is option B. Machine learning relies on large amounts of data to make decisions or predictions. Let's sum up what we've covered in this presentation. In this session, we have learned more about AI and the different parts of AI, such as machine learning, deep learning, and natural language processing. We then moved into generative AI. For each, we discussed its working and its real-life applications. That's all for the session. Thank you.